Hi guys, my name is Diego Soto.
My name is Roy Rosales.
And this is the first part of the Centripetal Force project with the water bucket.
This is my dog.
Alright, hi guys, this is the first part of the project with the water bucket. So first thing we're gonna do here, we're having it placed already on the bucket on the rope. I'm gonna go ahead and measure it. Oh shit.
Go ahead.
Nah, it shouldn't. So it's we measured it and it came out to 29 inches. So now we know that for the part of the math. So we're gonna go ahead and see it now.
Yeah, just say you converted it. Just say you converted it. Or just say we'll convert it. You accept that.
Alright, that's cool.
Just tell him.
Alright, so for starting off with the first bucket, so we know that our radius was 29 inches, which converts to 0.7364 meters. So in order to find minimum speed or the theoretical speed, we know that Fn minus mg equals ma. So we just do simple algebra and we just flip that. So now we have Fn equals mv squared divided by r minus mg. And we know that the net force is going to equal 0. So 0 equals mv squared divided by r plus mg. And then we could cancel out the m's now, since we have mg and m. We got two m's on this side, so now it's just g equals v squared. Once we have that, we multiply r to both sides, and we get square root of r squared equals gr, and we square root that, and we get v equals gr. So we plug that in, so we know that gravity equals 9.8, and that our radius equals 0.7368 meters, and we get that the velocity is 2.69 meters per second is the theoretical speed for the first bucket. For the first bucket, in order for the bucket to rotate without the water spilling. Alright guys, this is the second bucket we're using. So first thing we're gonna do, go ahead and measure it. Oh shit, it needs to go backwards. So it's around 18. Perfect, boom, done. And we're gonna go ahead and spin it. Oh shit, cut. Holy silent. Alright, so now going into the to the actual speed of our bucket rotation speed. We know that the equation is v equals 2 pi r divided by t, and so t equals time divided by a number of rotations. So the time it took for 4 rotations was 6, so 6 divided by 4, we got t equals 1.50. So now we plug in everything in. V equals 2 pi, and then the radius, which was 0.737 divided by 150, which was in the this, and we got that the velocity was 4.63 meters per second.
Tú quieres ser malo y no tiene ni un kiki, no tiene ni un kiki, no tiene ni un terremoto como pelota porque tú quieres friki, no tiene ni un kiki.
Hey guys, we're back. So now we're in our second part of a Centripetal Force project, the roller coaster. So we got our improvised version of a loop that we made here from our buddies, and well, let's get it started. First thing we're gonna do is measure the height. So you could see that it's about 4 inches. All right, so it's about 4 inches, the height, and we'll have the marble right here, and we're gonna go ahead and drop it.
Hey, let me drop it.
Yeah.
Get it, Gina.
I wouldn't do it. Alright, so now we're coming into the mat section of the roller coaster. So to find out the minimum speed, we have this equation of mv squared divided by r equals mg, and so we just we manipulate it and we get the equation of V equals square root of GR. So V equals 9.8 and the radius is 0.04. And we plug it in and it's 0.626 meters per second. Alright, so now heading into the energy needed at the start. So we're given the equation mgh equals or this equation. So we have all the things right here. So first we're looking at the total potential energy, and so we plug in M, G, and H. So we get that the total potential energy at the start is this number right here, this, and then after that we do the potential energy at the top of the loop, which is mg times 2r, and then we plug in all those numbers and we get 0.002352 joules, and then after that we are getting the kinetic energy at the top, and we plug it in and we get this number. So the total energy required is 0.002352 plus 0.000588, and that gives us 0.00294 joules. So the total energy available is 0.00987 joules, and the minimum height is 5/2 times the radius, so 5/2 times 0.04, it gives us the minimum height of 0.1 meters.